In this video, we'll discuss the basics of the derivative of the natural logarithmic function. F of x equals the natural log of x, f of x equals the ln of x, is known as the natural logarithmic function. And let's begin by a very brief review of the properties, some of the properties of the natural logarithmic function, f of x equals ln of x. It's a logarithm. ln is an abbreviation for a logarithm with base e. You would sometimes see this written as log, very rarely, see this written as log base e of x instead of ln of x. But it does represent a logarithm. The graph of the natural logarithmic function looks like this. There's an x-intercept at the point 1, 0. The domain, possible values for x, from left to right, is 0 to infinity, not including 0. 0 is not in the domain of the natural log of x. If you took the natural log of 0, it's undefined. The range is all numbers. This graph will fall forever very sharply as it approaches 0, and it will slowly rise as it moves to the right. It's increasing throughout its domain. This function will rise continuously as it moves from left to right, and it's concave down throughout its domain. So in this video, I'll discuss that if we have the natural logarithmic function, f of x equals ln of x, what is its derivative? What is the derivative of the natural logarithmic function? Well, for all values of x greater than 0, because the domain of the natural logarithmic function is all numbers greater than 0, the derivative of the natural log of x is equal to 1 over x. The derivative of the natural logarithmic function isn't a logarithm at all. It's 1 over x. So if we have an equation, y equals the natural log of x, its derivative, the formula for evaluating the slope of the curve, the rate of change of the natural log of x, is 1 over x. Perhaps a more useful formula for the derivative of a natural logarithmic function would be if you're taking the natural logarithm of any u, any quantity, any differentiable function of x. The derivative of the natural log of u is 1 over u, as you might suspect from the previous formula that I just discussed, but there's an additional factor here that's very important, times the derivative of u. This can be written in a little bit more of a condensed form, u prime over u. The derivative of the natural log of any differentiable expression u is equal to u prime over u. And this is the formula that you'll use more often. For example, if you're looking at an equation, y equals the natural log of 5x to the third, this derivative will have the form u prime over u. The actual calculus behind it is fairly simple once you know the formula. The u, unchanged, goes in the denominator. The u unchanged is in the denominator. In the numerator is the derivative of u. The derivative of 5x to the third is 15x squared. Many times when you are evaluating the derivative of a natural log, after this first step, after applying the formula, the fraction will be able to be reduced as it can in this case. 15 over 5 in lowest terms is 3, and x to the second over x to the third would simplify to being just an x in the denominator. The derivative of the natural log of 5x to the third is 3 over x. Let's do a few more examples that show how this derivative is evaluated. We'll do a total of 4 examples where we apply the derivative rule for the natural logarithmic function. The derivative of the natural log of any u, any differentiable function of x, u, is u prime over u. Let's begin with a fairly straightforward example. F of x equals the natural log of 2x. We want to find this derivative. Well, if we apply the formula, the u would be the 2x. We're taking the natural log of 2x. And then this derivative would have the form u prime over u. So if f of x equals the natural log of 2x, the derivative of f of x is, well, the u, what you're taking the natural log of, unchanged, goes in the denominator. And in the numerator is u prime. The derivative of 2x is 2. Let's simplify that. 2 over 2x reduces to 1 over x. The derivative of the natural log of 2x is 1 over x. A little bit more complicated. Let's take a look at f of x equals the natural log of x squared plus 1. In this function, we'll let u equal x squared plus 1. And again, all we have to do is express the derivative as u prime over u. So the derivative of this f of x is equal to, we're always going to start out with a fraction, the u, unchanged, x squared plus 1, is the denominator, and the numerator is the derivative of that. The numerator is u prime, the derivative of x squared plus 1. The derivative of x squared plus 1 is 2x. Now, unlike example 1, 2x over x squared plus 1 cannot be simplified. The derivative of the natural log of x squared plus 1 is 2x over x squared plus 1. For the third example, f of x equals x times the natural log of x, we have a product. We have x times the natural log of x. The product rule will have to be applied. Remember, the product rule says that if you're taking the derivative of f times g, f and g are two differentiable functions like x and the natural log of x, that's equal to the first factor times the derivative of the second plus the second factor unchanged times the derivative of the first. In this problem, the first factor is x and the second factor is the natural log of x. So this derivative would be the first factor x times the derivative of the natural log of x. The derivative of the natural log of x. Well, when you take the derivative of the natural log of x, I'm always going to write that derivative as a fraction, at least to begin with, and its form is u prime over u. So the denominator is the x unchanged, and the numerator is the derivative of x, which in this case is 1. Plus, using the product rule, the next thing we have is the plus sign, and then we're going to take that second factor unchanged, and in this problem the second factor was the natural log of x, times the derivative of the first factor, the derivative of x, which is just a 1. Simplifying this, we had in our first term x times 1 over x, x times 1 over x. Well, this product, the x's are going to cancel out, and we have just a 1. X over 1 times 1 over x is just 1. And in the second term, the natural log of x times 1, multiplying something by 1 doesn't change its value. So I just have 1 plus the natural log of x. The derivative of x times the natural log of x is 1 plus the natural log of x. Our final example, the natural log of x to the third power, will require the chain rule. The chain rule. One way to express the chain rule is that anytime you have a quantity that's raised to the third power, that derivative, well, you can use the normal power rule, but then you have to multiply by the derivative of the u. So in this problem, we have the natural log of x to the third power. That's what our u is. So what I'll do is I'll bring the 3 to the front, write the natural log of x to the second power, but then I have to multiply by the derivative of what was inside the parentheses, the derivative of the natural log of x. Now the derivative of the natural log of x, the derivative of any natural logarithm, is a fraction in the form of u prime over u. In this problem, we're taking the natural log of x, so that x unchanged goes in a denominator. And in the numerator, there's a 1. The derivative of x is 1. Simplifying this, we have 3 times the natural log of x squared times 1 over x. When you multiply something that doesn't have a fraction times something that does have a fraction, you can put the 3 times the natural log of x squared in the numerator and the x in the denominator. And this is as simplified as we can express this derivative. 3 times the natural log of x squared over x.